This is geometry, section 7.2, similar polygons, page 502. So you probably understand similar a little bit, but let's go through it again. We start with this. This symbol means equal, which means same measure. Okay. Same measure means that somehow something's equal, and it's like Dylan and Aubrey could have the same ACT score. That would be equal. Okay. This symbol means similar, and it means same size, same shape. And to be honest with you, I meant to, on the one above it, measure should be same size. Is how I meant to say that, and I said measure, I'm not sure why. Now if you put these two symbols together, they form this, which means congruent. And we've been talking about congruent for a long time, but, similar means, I am really messing up. Similar means same shape. Sorry about that. And then congruent is same size and same shape. Okay. All right. So we're going to discuss this one today. But it's nice to know the different figures and how they came about and what they mean. Similar polygons are formed by dilations. So in other words, we take a polygon and we enlarge it or we reduce it. Okay? It says a similar transformation occurs when a figure and its image have the same shape, but not necessarily the same size. Every figure is similar to itself. Okay? So, but it doesn't, just so you know, that every figure is similar to itself. If you take a look at example 1 there, it says determine whether the given polygons are similar. You can look and see how one can be transferred over to the other by a dilation. Okay? We're not going to spend a lot of time on that. What we're going to spend a lot of time on is what it means to be similar. Okay? There are two things that happen in similar polygons. Number one, corresponding angles are congruent. That means that however many angles there are, that they match up with the other one's angles, and they are congruent. That means that they have the same measure. The second thing is that sides are in proportion. Okay? The sides are in proportion. So let's say that I have, and I'm just going to use a triangle. The book uses a quadrilateral, which is actually not a bad idea because, you get more figures to look at. But let's say we have this, and how I say it is really important. Whoops. I'm going to say that a triangle ABC is similar to triangle DEF. That means that angles are congruent, corresponding angles. So that means that this is true. That this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle. So angle, if I can write it out to angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. That's what that means. The sides are really what's kind of the important thing. If we look at this picture, we can say that side line segment AB, well, no, let's talk about lengths. It's be lengths. So AB, God, I did it again. AB over DE, so its corresponding side, equals BC over EF equals CA over FD. Okay? So those sides are in proportion. So on your assignment, one of the things that you're going to do is, it says, it lists all the pairs of congruent angles and write a proportion that relates to the corresponding sides for each pair of similar polygons. So you are going to basically say which angles are equal, like this, and then you're going to say, and this is what we call an extended proportion. You're going to say all the sides. Now in a triangle, we have, oh, excuse me. In a triangle, we have 3 sides that are congruent, but like a quadrilateral, there would be another 4th one, wouldn't there? A pentagon, there'd be another 5th one. Okay? You understand that? Eltra, you understand that? Okay, I can read it to you. AB over DE equals BC over EF equals CA over FD. Does that make sense? Okay. Questions about that? All right. Now, do I need a picture to say which sides are in proportion and which angles are? No, I can go just from this, can't I? All right. So, all right. The ratio, what's ratio? What's another word for ratio? Fraction. The ratio of the lengths of corresponding sides, so the fraction of similar polygons is called the scale factor. It's called the scale factor. So each one of these are a scale factor. Okay? So if I had a triangle that looked like this, and this was N, this was Q, this is P. This is from the book. If you're not seeing this, this is guided practice, and this is T, R, and S. Now what I'm going to do is, I'm not going to write down which is which, but I'm going to show you this angle N is congruent to this angle R, and this angle S is congruent to this angle Q. This is 12.5, this is 15, this is 11.5. This is 12, this is 10, and this is 9.2, 9.2. Okay. TR is 12. It's 12. Okay. It's on the bottom of page 504. Okay. So my question is, what's the scale factor of this particular triangle? Well, we're going to find matching sides, correct? How do you find matching sides? Okay, the angles. N matches R, and Q matches there. So this side here doesn't have to match this side here. So if I say I want the scale factor from triangle RST, and it's 2, let's put 2, triangle, what matches R? N? What matches S? P? No. Q? S. What's the scale factor from this triangle to this triangle? Well, 12.5, correct? Over what? 10.
Isn't it NQP?
NQP. Thank you very much. Thank you. I feel like a Monday here. Making a lot of little errors. Let's bring that up a little bit. Okay, so did I show you this yesterday? I don't remember which class it is, but you can't have a decimal in a fraction. So we need to multiply that by 10. So we get 125. If you multiply the top by 10, you have to multiply the bottom, so it's 100. So dividing by 25, we get 5 over 4. That is interesting, isn't it? Okay, 5 over 4. Question. Well, first of all, before I ask this question, notice that I went from RST to NQP. If I went from NQP to RST, what would this fraction be? It would be 4/5. It would be a reduction. Okay? It depends on how they state it. Do you understand that? Okay, now, would you do me a favor? Grab your calculator, and let's keep RST to N. Did I get that right? Okay, I want to do the perimeters. So do the perimeter of this one. Add those up for me and tell me what you get.
39 for the bigger one.
Okay, what's the smaller one?
31.2.
31.2. Okay, I'm going to see if the author did this right. Okay, so it's 390 over 312, correct? Can we simplify that? It's what?
You can do it by 3.
Okay, by 3, so it'd be 130 over.
Maybe also 5/4.
How do you say that? What did you say?
I said it would also be 5. You can go by 6.
Okay, so it simplifies down to what?
5/4.
Notice the perimeters are in the same, but I'll warn you, the areas are not that way. Okay, the perimeters are in the same. Okay, got that? Now, one of the things we can do with similar figures is we can solve for unknowns. Okay, now I'm taking triangles once again, but let's take this triangle here. This is guided practice on page 505. This is J, and this is M, and this is L. This is 3y minus 2 as the side. This is 4, and this is 6x minus 3. Okay? We have another triangle that is similar to it, and I'll give you the similarity statement in just a minute. This is S, this is Q, and this is T. Q is congruent to J, and T and M are congruent. This is 3, this is 5, and this is 2. Okay, now the question, well, first of all, I'm going to tell you the similarity. Triangle JLM is similar to triangle QST. Okay? And I want to solve for X and Y. Okay? I want to solve for X and Y. So I'll start with X. X is LM, right? Okay, so I want to put 6x minus 3 over its corresponding side. If I look here, here's LM, that would be ST, correct? Which would be 3. Notice I didn't even look at the picture. Did you notice that? I just looked at the letters. Angel, we good? Equals, now I have to get 2 corresponding sides that are there. And the only one in this triangle that is a solid number is 4, right? So I put 4 in the same spot that I came from. So I go from this triangle to this triangle to this triangle to this triangle. And what matches JM? QT, which is 2. Now I cross multiply. 2 times 6x minus 3 equals 3 times 4, which is 12. Using the distributive property, I get 12x minus 6 equals 12. I'm going to subtract a negative 6 or add 6 to both sides. And I get 12x is what? 18. So x equals 18 divided by 12, which is 9 over 6, which is 3 halves? 3 halves. Okay. Now, I could do the same thing with the y, and I'm not going to show this, but I could take 3y minus 2, which is JL, over QS, which is 5, equals, and you would use the same, this side would be the same because it's the 2 that are known. Okay? Does that make sense to you? Now, I don't know, does anybody remember doing this in 7th grade? Yeah, we did it actually in 7th grade, a little bit. Not maybe this in depth, but. Okay, so turn to page 507.
I have a question.
Yeah,
Okay, for y, could you still use 4 over 2?
you would use 4 over 2. Do not use, that is a great question, and I'm going to extend on that. Do not use the value that you solve first if you can possibly help it. Why? What? It might be wrong. That's exactly right, Nelcha. It might be wrong. And so if you made a mistake on it, it carries over then into the next one. Okay, so always use what they give you. Okay, so we're going to be on page 507. We're going to look at numbers. We're going to start with 12. We're going to go 12 through 16. Then we're going to do 18 through 28. Okay? All right? And I'll have Chinny put that up there in just a minute. I want to look at a couple if we can do that, please. 12 and 13. I'm going to tell you right now, 13, there's a lot of answers because you're going to match up angles that are congruent, and then you're going to write sides that are in proportion. Okay? 14 and 15, you tell me whether they're similar or not. In order to tell me whether they're similar or not, people, you have to decide if all the angles, corresponding angles, are congruent and the sides are in proportion. If the angles are not equal, can you stop and say they're not similar? Yes. So always check angles first. They're much easier than looking at sides in proportion. You understand what I'm saying? All right, for example, number 14, you can tell the angles are not equal, right? So automatically, no, angle L is not congruent to angle M, or angle W, sorry. And so, no, they can't be similar. All right. But now I want to look at number 23. I'm going to do a couple here. 23, it says find the perimeter of the given triangle. It says triangle DEF. We want to find the perimeter of triangle DEF. We want to find the perimeter of triangle DEF. All right? If ABC is similar to DEF, so this is A, B, C, and this is DEF, correct? Little tiny F. Okay, this is 3, this is D, this is E, and this is F. Okay, 5, 7, and 6. Okay, how do you do this? Any ideas? What side matches DE? Because DE is known on this one, right? Is it says ABC is congruent to DEF. So what sides matches the 3? What's its corresponding side? What, AB, which is 5, right? So the relationship is what? We're going from ABC to DEF. It's what? 5 over 3. Okay? So the perimeter is what? The perimeter of this one is 18 over what? Is that true? Can I do it like that? All right. So I have 5x equals what? 54. Divide by 5, and I get x equals, what is it? Louder, please.
It'll be 10.8.
Thank you, 10.8. What if I mixed up and I went 3 over 5 is x over 18? Will I get the same thing? Yes, as long as you go from one triangle to the other, you're fine. Do you understand that?
How do you get 18?
Where did I get 18? I added these up, the perimeter, because we're dealing with perimeters, right? I'm sorry. Okay. Now let's take a look at 28, please. And then I'll let you work. It says two similar rectangles have a scale factor of 3 to 2. The perimeter of the smaller rectangle is 50 feet. How do I find the perimeter of the larger rectangle? How do I set that up? Louder, please. I'm on 28.
50.
What's the scale? What's the scale factor? 3 over 2, right? Where does the 50 go?
On the top. Bottom.
It says the small rectangle is 50 feet, so it goes on the bottom. What goes on top? There you go. Do you see? You just read it, put things where they are. So I had the bigger rectangle over the smaller, bigger over smaller. Any questions on that? All right. So you know your assignment. Your assignment again, Chenny, would you put that up there? Is page 507, 12 through 16, comma, 18 through 28. Okay? Looks like I'm letting you work on it tomorrow. I don't know if that's a good idea, but I'll be ready for the next section. Okay?